Okay, so in this example, we're going to study another optimization problem. It states that a man's on one side of a 3-kilometer wide river at some point A, so here's the point A, and on the opposite bank, 8 kilometers south, is a point B, which is their destination. And so the point is, we want to get from A to B as quickly as possible. And so the problem is we can row at 6 kilometers an hour and run 8 kilometers an hour. And so the question is, how do we minimize the travel time from A to B? And so the point you see is that I could, in theory, row straight across, because that's the shortest time to row, which I'm slower at, and then run all the way down to B. Or perhaps I go straight from A to B, because that's the shortest distance I would travel, right? Or perhaps there's like some magical point D, which is somewhere in between C and B, where I row sort of diagonally and then run the rest of the way. And so the question is, what's my strategy to minimize the time that I travel from A to B? Okay, so in order to solve this problem, actually the book gives us a nice little hint here, which is to let x be the distance below C that I travel by boat. Okay, so I'm assuming, right, I'm starting at A, and I'm going to row across the shore to some point which is x meters or kilometers, x kilometers below the point C. So if x equals 0, I'm going straight across and then running the rest of the way. If x equals 8, then I'm going all the way from A to B directly. Okay. And so for this question, my goal is to minimize time, so I need some relevant equation that will measure time. In this case, the relevant equation is the distance equation. Distance equals rate times time, or rearranging, time equals distance over rate. Okay, so if I want to figure out the time it takes me to travel, I need to figure out distances and rates. It turns out the best way to approach this is to do it in two parts. So first, let's think about the running time, right? So that's the easier of the two. So let's assume I've already landed at some point D across the shore, and I want to know, how far do I run and how fast do I run? Well, the distance that I run, if x is the distance from C to D, the distance that remains from D to B is 8 minus x. My running rate is given in the problem as 8 kilometers an hour. Okay. So combining these two things, the time it takes for me to run from D to B is 8 minus x over 8, right? Distance over the rate. So that's the total time. Okay. So this is the time it takes for me to run from D to B, but I guess the second question is, how long does it take me to row across the river from A to D? So we'll set up a similar type question. In this case, how far did I wrote swim here, but I guess we're rowing but in a boat. In any case, how long or how far do I have to go from A to D? Well, if I look at the picture, I see a right triangle formed between A, C, and D. So the length that I travel across the river has to be the length of the hypotenuse of this right triangle, with side lengths 3 and x. In other words, the distance I swim should be the square root of 3 squared, or 9, plus x squared. Square root of 9 plus x squared. That's it. So that's the distance, or the length, of this purple line, okay? The hypotenuse. The rate at which I go, again, is given in the problem as 6. And just as above, with these two things together, I can figure out how long it takes for me to swim or row, which is distance over rate, which is root 9 plus x squared over 6. Okay, so there's a lot of pre-work, but altogether it gives us a lot of useful information, namely, the total time it takes for me to go from A to B is the sum of the times it takes me to go across and run down. So my time t is the sum of the time it takes to run with the time it takes to row. Okay, so this is the thing I want to minimize. My goal is to minimize the function t. So quite a bit of back work in this problem, but with that set up, first, right, we know I'd like to set up an interval. In this case, I claim that the right interval to think about is 0 to 8. Well, why? Remember that x is the distance that I travel between, or from C down. So of course, the two extreme cases are either x equals 0, in which case I go straight across and then down, or x equals 8, in which case I go straight down to be rowing the entire way. Okay, and so x should be considered between those two extremes, and so in this case it looks like I'll be able to use closed interval method. Okay, so optimize t, we want to find the minimum. This is straightforward. First, take the derivative. Okay, of course I'm skipping all of the actual computations here, but it's a good way to check for yourself, right? Can you take the derivative of this and land on the same derivative I got? Okay. Once I have my first derivative, I'm going to find my critical numbers. So when does the derivative equal 0? When does it not exist? When it equals 0, again, I claim with a little bit of algebra, you should be able to convince yourself that x equals 9 over root 7 is a critical number, and you can check the domain, right? This denominator never equals 0. It's always positive plus a positive in the square root, so there's no square root issues. Yeah, there's no domain restrictions in this case, so there's no other critical numbers, just the one at 9 over root 7. Okay, so plugging in, I'm going to check using my closed interval method. I'm going to just compare the endpoints, 0 and 8, and 9 over root 7, the critical number. Plugging all of these into my time function, this is the amount of time it takes in total, we see, although they're quite close, in fact, the best I can do is at that critical number, 9 over root 7, in which case it takes me 1.33 hours as opposed to 1.42 or 1.5 hours in the other two extremes. So that's it. So what it tells us is that we should swim approximately 3.4 kilometers south of the position across the river, so a little bit less than halfway. I thought this was a cool example because it's certainly non-intuitive to me, right? I wasn't sure what the correct answer would be, so it's surprising to me that the best way to get across this river is to swim a little bit before halfway and then run the rest. Okay, so if you have any questions, please let me know.